Greeting to all, this is Yi Zhen with metric number 298822. Today I'm going to present about the assignment 1 of SQQSK 2073 regression modeling. Alright, so let's take a look on what the topic that we are going to discuss today. The first is historical origin of the term regression. The second is statistical versus deterministic relationship. The third is regression versus causation. The fourth is regression versus correlation, and the last one is simple and multiple regression model. Okay, so have you ever wondered how or why, where is the term regression come out? It's actually first documented by the statistician or the scientist, which is Francis Galton, in the 19th century. At that moment, Galton was interested about the high inheritance with the thought of tall parents will have tall children. So Galton started to collect the data and conducted the test. However, the data shows that the tall parents' children will not quite as tall. Therefore, Galton published his result in the paper called Regression Towards Mediocrity in Hereditary Status. Okay. So let's take a look on what are the difference between the statistical relationship and deterministic relationship. So statistical relationship is not an exact relationship and subject to some degree of randomness. So in this relationship, the natural variability exists in both measurements, which is x and y. So it essentially deals with random or stochastic variables where the variables have probability distribution. It might be discrete or continuous distribution, for example like binomial, Poisson, normal distribution, and so on. For example, the relationship between height and weight. Next one, the deterministic relationship. It is an exact relationship between the predictor x and the response y. So in this relationship, we're not dealing with the variables that are random or stochastic. For example, the relationship between the diameter and circumstage of a circle. Okay, so now, regression versus causation and regression versus correlation. What are the difference between them? So regression is a statistical method, okay, not deterministic, that used to model the relationship between a dependent variable y and one or more independent variable x. It does not show the cause and effect relationship, and it also does not necessarily imply causation. Whereas causation indicates a relationship while changing a variable directly affects another, and it basically implies a cause and effect relationship. What about regression versus correlation? Regression gives a numerical method for trying to predict one measurement variable from another. It is not skew independent, and the derived regression equation depends on the unit of each variable involved. Whereas correlation measures the strength or the degree of linear association of a certain type of relationship between two measurement variables. It is skew independent that varies from +1 through 0 to -1. Therefore, it can identify whether a particular parameter will positively or negatively impact the accomplishment of a specific target. Okay, so the last one, difference between the simple linear regression and multiple regression. So what makes them different is the amount or the number of the independent variable x. So for simple linear regression, it examines the relationship between one independent variable x and one dependent variable y by a linear function. So the estimation equation is y hat equals to b naught, which represent the intercept, plus b1, which represent the slope, times with x. Whereas the multiple regression examines the relationship between one dependent variable y and one or more independent variable x. So it models complex relationship between model, and the equation is y hat equals to b naught plus by x1 plus b2 by 2 plus until bixi, which is the number of the variable x. Okay. Thank you for listening, and that is all from me. See you. Bye.